Land Before Time presents. Today we're going to be taking a look at trees. Not those trees, though the game is kind of wholesome with a terrible comeback mechanism. I still love the game though. Alrighty, getting back to the problem. Given the root of a binary tree, invert the tree and return its root. Goal: invert the tree. This is a pretty straightforward problem. I only have one question. Can the tree be null? Yes, the tree can be null. Okay, moving on to some examples. Let's start with example number 2, where we have 2, 1, 3. And we know that the end result is going to look like 2, 3, and 1. So we know that in order for that to happen, we would need basically choose left to equal 3 and choose right to equal 1. And the real question is, how is this going to happen? The first thing that comes to my mind is we want to use something like recursion. So if we use something like recursion, we know that if we start over here, this is going to be our current root, and then we're going to traverse left, which that will lead us over here. And when we try to go left and right of this one, we realize it's going to be null, and we know that that's what our base case is going to be. So we will come back up to 2, and we'll go ahead to the right side, and this will be the right side. And again, we'll do the same thing where we try to traverse down to the left and right of 3 to realize that is null. When we do that, then now we're left with the root as 2, left as 1, right as 3. So what that means is we probably want to say that 2.left should be whatever the right value of this is going to be. So probably it'll look something like this. And for 1, we want to replace that with the left. And if we do that, we know what we're going to end up with is something like 2, 3, and 1. And now the real question is, will this work for a larger example, such as example 1 over here? Let's just go ahead and work it out. So we can see that we have 4, 2, 7, 1, 3, 6, and 9. And again, we're going to start at the 4 here. So our root is going to be 4. Then we are going to come down to the 2, which will be our left. And since we still have more to process here, this will actually transform into our current root at this point. And left will be 1. So when we try to go to the left and to the right, we'll see that we will get null. So then we go back up here and we try to go to the right, which we will get 3. And from our previous example, we know that these will get swapped. And when they get swapped, we will have 3 and 1. And we've swapped the subtree to 3 and 1. So now we're done with this subtree over here, and we go back up to the root. And at this point, our left is 2. And we go back up to the root and we get 4, and we come down to the right. And when we come down to the right, obviously we will do the same steps again, and this will eventually look something like this, where we will have 9, then 6. We will have the stack now be our root is 4, our left is 2, and our right is 7. So now when we switch 2, 3, 1, and 7, 9, 6, now we will end up having the result looking like 4, 7, 2, 9, 6, 3, 1. Since we've had to swap the left and the right subtrees, all of the children will also get swapped in that case and get inverted. Typically, I would say, let's take some time to gather our thoughts and blueprint our solution. However, the blueprint and the code in this particular problem is almost a one-to-one match. So let's demonstrate our rockstar coding skills and code the solution. And there we have it, successfully inverting a binary tree. If you enjoyed this video, stay tuned for the next one, and enjoy Hot Pocket while you're at it.